Calculating how much precipitant to use. To measure the nickel content in steel, the alloy is dissolved in 12 molar hydrochloric acid and neutralized in the presence of citrate ion, which maintains iron in the solution. The slightly basic solution is warmed and dimethyl glyoxime, or DMG, is added to precipitate the red DMG nickel complex quantitatively. The product is filtered, washed with cold water, and dried at 110 degrees. If the nickel content is known to be near 3% by weight, and you wish to analyze 1.0 grams of the steel, what volume of 1.0% by weight alcoholic DMG solution should be used to give a 50% excess of DMG for the analysis? Assume that the density of the alcohol solution is 0.79 grams per ml. Now, the very first thing we need to consider here is our basis. We are basing our calculations on, on 1 gram of the steel, which contains 3% by weight nickel. So, as a starting point, let me write here as our basis for our calculation. We have 1.0 grams of the steel, and it contains 3.0% of nickel. Therefore, the weight of nickel in 1 gram of steel will be 0.030% times 1.0 grams, or that is 0.030 grams. Now, given the weight of nickel, we need to calculate the weight of DMG that will react with nickel. However, we need to know the formula of the red DMG nickel complex. How do we determine that? Well, we don't know the reaction involving nickel and DMG. To form the nickel DMG complex. However, we are given the atomic weight of nickel, the formula weight of DMG, and the formula weight of the red DMG complex. So, by trial and error, let's say we have 58.69 grams of nickel and reacting this with 1 mole of DMG. So this will be plus 116.12 grams, and it will give us around 174.81 grams. Now, the complex is about 288.91 grams per mole. So, this is not the correct formula. If we have 2 moles of DMG, so we can have 58.69 grams. And let's say we have 2 moles of DMG, so 2 times 116.12 grams, it will give us a value of 290.93 grams per mole, which is close to 288.91 grams per mole. Therefore, we can say that 1 mole of nickel will react with 2 moles of DMG to form the nickel-DMG complex. So, we can now use this to solve for the weight of DMG. And this is equal to the weight of nickel multiplied by our gravimetric factor. We know that there are 2 moles of DMG times the formula weight of DMG reacting with 1 mole of nickel multiplied by its atomic weight. Okay. Substituting the values, we get 0.030 grams times, you have 2 moles of DMG multiplied by its formula mass, 116.12 grams, divided by 1 mole of nickel multiplied by its atomic weight, 58.69 grams. Therefore, the weight of DMG is equal to 0.1187 grams. Okay, now, this is the weight of the pure DMG. We now need to calculate the weight of the DMG in solution. So the weight of the DMG solution can be determined using the percent DMG, percent by weight of the alcoholic DMG solution. Okay, so again, we would like to know the weight of our DMG solution. To determine that, we can get it from percent by weight DMG in solution. And that is equal to the weight of pure DMG divided by the weight of the DMG solution times 100. Substituting the values, we have 1.0% of the DMG in solution. We know the weight of DMG, which is equal to 0.1187 grams. We can now solve for the weight of the DMG solution times 100. And therefore, weight of DMG solution will be equal to 11.87 grams. Next, we need to solve for the volume of DMG solution. We can get that from the density. So we have here density of DMG solution. That is equal to the weight of your DMG solution divided by the volume of DMG solution. Substituting the values, we're given the density 0.79 grams per ml, and that is equal to the weight of DMG solution, 11.87 grams, so that we can calculate for the volume of the DMG solution. So the volume of our DMG solution is equal to 15.025 milliliters. Now, according to our problem, we need to determine the volume of the DMG solution with 50% excess. And therefore, we need to determine for the 50% excess DMG solution, the volume of DMG solution required, meaning with 50% excess DMG, that will be equal to 1.5 times the volume of our DMG solution, which is 15.025 ml. That will give us 22.54 milliliters. And that's the end of our calculations. So the volume of DMG solution required is 22.54